Physics skills, mathematical addition of noncollinear vectors. Information you need to do the PS4 assignment. Vectors can only be added when directed towards the north, east, west, or south. Vectors that do not run along these headings must be separated into their news components. If a vector is being subtracted, its magnitude is the same, but its direction of application is opposite to the given direction. For example, if we are given negative 4.3 newtons west 34 degrees of north, that is equal to positive 4.3 newtons east 34 degrees south. So if we are given a negative value in the question, we will change it to a positive by reversing the direction given in the vector. An example of a vector direction is west 24 degrees north. If someone was facing west 24 degrees north, they would begin by looking directly west, then sweeping 24 degrees towards the north. This direction could also be expressed as north 66 degrees west, as someone could look directly north, and then they would swing 66 degrees towards the west to look the exact same direction. This means a question can have two different answers. The magnitude of both will be the same, but the degrees could differ. That is why the answer key always has two answers given. If vectors have been properly added tip to tail, given correct position and drawn to scale, it is possible to determine the direction and the magnitude of the resultant vector by using a ruler and a protractor, so the above calculations are not necessary. If we know the direction and speed of our canoe, as well as the direction and speed of the river, we can calculate where we are headed and how fast we are moving. In the quiz, the examples, and in the assignment, all calculations will be made to one decimal place. Example 1, 2.3 meters north plus 3.6 meters south, 26.4 degrees east. The first thing I would do is draw out 3.6 meters south, 26.4 degrees east. We are going to start by drawing a triangle. First we go south and then we go east. So we draw south first, and where we finish, we then draw east. Make the hypotenuse by drawing a vector. Its direction is from where we started to where we finished. We started here, so we will draw a vector from where we started down to where we finished. The angle from where the triangle was started was 26.4 degrees. So facing south, going towards the east, this angle is 26.4 degrees. The hypotenuse of the triangle is 3.6 meters. So we will use cosine to find the value of the adjacent side and sine to find the value of the opposite side. We will rewrite the original equation, substituting in 3.2246 meters south plus 1.6007 meters east in for what was originally 3.6 meters south, 26.4 degrees east. South is larger than north, so I'm going to change both directions to south. So positive 2.3 meters north then becomes negative 2.3 meters south. I'm going to merge both south directions. That gives me 0.9246 meters south. And now I have to draw the final triangle. So when I draw this final triangle, I can either draw south first and then go east, or I can go east first and then south. In this example, I'm going to draw south first. So I went south 0.9246 meters, and then I drew a vector going east at 1.6007 meters. I will then draw a resultant vector going from where I started to where I finished. To find the length of that vector, I'm going to use Pythagorean theorem. So 0.9246 squared plus 1.6007 squared all together, and then square rooted, gives me 1.8 meters. In order to find the angle for this vector, I have to use tangent. So I'm going to use opposite over adjacent, and then I will inverse tan that answer to get theta by itself. Example 2. The first thing I want to do is deal with that negative. So I'm going to start by turning the negative vectors into positive vectors by reversing the direction. So north 48.0 degrees west becomes south 48.0 degrees east. I will draw both vectors. First, I went west and then south, and the angle is 36.4. And the second vector, I went south first and then east, and then measured over 48 degrees. I use sine and cosine to find the opposite and adjacent sides to each of the angles. Now I will sub those new values in for those original vectors. I wrote 2.1956 meters south, and then over here I took the 2.0074 meters south and placed it right next to it because they're both south and I know they will merge together. I took the west and wrote it next. Then I wrote the east next to that, knowing that west and east run opposite of each other, and they will have to be merged. Between west and east, west is a larger number, so I know west will win, so I'm going to change both vectors to west. So the 2.2294 meters east becomes negative 2.2294 meters west. I will now merge the south vectors, and I will merge the west vectors. Now I can draw my final triangle. I wrote south first, so I drew a vector going south. And where that vector ended, I drew my next vector, which went west. And now I will draw my resultant vector by going from where I started to where I finished. I'll use Pythagorean theorem to find the length of the resultant vector. So the square root of 4.2030 squared plus 0.7487 squared equals 4.3 meters. To finish, I need to include the direction of this vector. So I will use tangent. This is where we started. So 0.7487 is our opposite side. 4.2030 is our adjacent side. And inverse tan of 0.7487 divided by 4.203 is 10.1. We went south first, and then we turned 10.1 degrees towards the west. Final example. The first thing I do is turn negative vectors into positive vectors by reversing the direction. So negative 8.1 meters north 32.7 degrees west becomes positive 8.1 meters south 32.7 degrees east. I now draw each vector. The first vector went west, then south. The second vector went south, then east. The third vector went north, then west. We will use sine and cosine to find the sides opposite and adjacent to each of the given angles. Now we will substitute into the original equation. The easiest way to line this up, in my opinion, I will take this south value and add it to this south value, and then add it to this north value. So south, south, and then north. Then I will take this west value, this east value, and this west value and add them all together. South is greater than north, so I change the north values to south. And the west values are greater than the east value, so I change the east value to west. So positive 3.5530 meters north became negative 3.5530 meters south. And the east value, which was 4.3760 meters east, becomes negative 4.3760 meters west. I will now add all the souths together, and I will add all the west values together. And that gives me a total of 8.0565 meters south, added to 3.6616 meters west. So draw the two remaining vectors. I went south and then west first. So south and then west. I then draw my resultant vector from where I started down to where I finished. I will then want to solve for the length of that side by using Pythagorean theorem. So the square root of 3.6616 squared plus 8.0565 squared equals 8.8 meters. I then want to get a direction for this vector. Again, I go to where I started, and that's where I want to find the angle from. The opposite side is 3.6616. The adjacent side is 8.0565. So to find the angle, I took the inverse tan of opposite 3.6616 divided by adjacent 8.0565, and that gave me 24.4. I went south first. The angle is 24.4 degrees, and I went west second. And that's it. You are ready to do the PS4 assignment.